Hi guys, we are here today. This is your statistics class. We're looking at lesson 6.4 in statistics. That is going to be confidence intervals for variance and standard deviation. So we've looked at a confidence interval for the population mean. We've looked at a confidence interval for the population proportion. Now we're going to look at creating confidence intervals for variance and standard deviation. Okay. And think about the variance and the standard deviation kind of measure the spread. And what we're thinking about, where this tends to be used, say if you are manufacturing parts and these parts need to fit together. Well, if the things need to fit together, we need to have a small variance in size on those parts in order for them to fit together like they should. If you have a wide variance, then chances are your parts are not going to fit together. Or say, for instance, if you're doing a medication and the medication is supposed to be, 5 milligrams of the dosage, well, you want a small variance there, a small standard deviation in the amount of medication that is in each pill so that you're sure that your patients are getting the appropriate dosage of the medication. Okay. So this is what we're looking for now then, the statistical distribution that we're going to use to calculate the confidence interval for standard deviation is called chi-squared. Okay, it's spelled like this. It's going to be chi-squared. Okay, the symbol for it is this fancy little X. And that's going to be chi-squared. Okay, chi-squared, it's a squared number, so it will never be negative. Okay, so that's one of our characteristics of this. Chi-squared is going to be your sample size minus 1. We're going to multiply that by the sample standard deviation divided by the population variance. Okay, this is our formula that we're going to use for this here, okay? All right, so as we're looking at this, okay, I've talked about the fact that it's going to be squared, okay, so it's never going to be negative. It is skewed right. All right, with the fact, think of our sample, our normal distribution, a normal distribution. All right, we would have it looking like this. Okay, and remember that 0 was always right there in the middle, and we would have positive numbers on this side, and we would have negative numbers on this side. Okay, well, the chi-squared is always going to be positive, so this is going to be skewed right. All right, so this is going to look like this. Okay, it's going to be over here, always in that positive quadrant. Okay, and the area underneath here is going to be equal to 1. We're used to that idea as well, right? Okay. Remember with our z-curves were single curves. The chi-square is going to be like the t-curve. It's going to be a family of curves, okay? And the curve that you choose is going to depend upon the degree of freedom. If you look down there at the bottom of page 344, you'll kind of see that idea of the family of curves, okay? I could have a curve like this and say this is a degree of freedom of 1. If I have maybe this curve looking like that, that might be a degree of freedom of 4. Say something like this might be a degree of freedom of, say, 9. And maybe we might have something like this is a degree of freedom of 15. Okay, notice that the higher the degree of freedom, the more symmetric the curve is. It's still not going to be perfectly symmetric. It's still going to be skewed right, but the higher the degree of freedom, the more symmetrical it's going to be. Okay, these are all chi-square distributions. All right. So notice here the idea, the curve is positive. We do have a family of curves. It's based on the degree of freedom. Okay, the area under each curve is going to be 1, and these are going to be positively skewed. All right. As we look at our curve, okay, so we have that right there. Oh, that's quite a curve, isn't it? Got a little carried away there. Okay, so we've got this right here. I was trying to make sure that I keep it skewed and don't have it, looking too normal. Okay, with this, we're going to have two chi values. All right. They're going to be two different critical values. We're going to find these from a table. Okay, this is going to be our chi squared right. Over here, we're going to have a chi squared left. Okay, so what we're going to do as we find these, we're going to find alpha. And in your book, you don't see the alpha so much, but when you look in the back table, the alpha's back there in the back table. Alpha is going to be 1 minus your confidence level. All right, they don't call it alpha in the textbook, but like I said, that's what you're going to find on the back when you're looking up things. Okay, so 1 minus your confidence level. So say if I have a 95-degree confidence, then that alpha is going to be 1 minus this 0.95, so it's going to be 0.05. All right. I'm going to wind up taking this right here, and I'm going to divide it by 2. So I get this 1 minus 0.95 divided by 2 is going to give me this 0.05 divided by 2 is going to give me 0.025. And this is going to be my chi right. Okay, that's going to be my chi right. My chi left, for my chi left, I wind up taking, I've got this value right here where I've taken, sorry, I'm looking for my thing that I've got right there. 1 minus the confidence level divided by 2. I'm going to wind up taking this right here, and I'm going to do 1 minus 0.95 over 2. Okay, this is what I'm going to wind up doing. You'll notice in your book that they do note the fact that that negative affects that over there, and that this is going to be the same as 1 plus your confidence level over 2. They wind up being the same thing depending upon, it winds up being the same amount either way that you do that. So if I look from my left, I'm going to do 1 minus 0.95 over 2. So this is going to come up to be 0.975, and that is going to be my chi left. All right. Okay, sorry. All right, so as I'm looking at this, so to find the, let's look at this example that they have here in the book for you. I'm looking at example number 1 for just a second. Okay, it says, find the critical values for chi right and chi left for a 90% confidence interval when the sample size is 20. Okay, so if I've got a sample size of 20, so n equals 20. All right, so my DF is going to equal 19 because I'm going to take 1 off, right? My degree of freedom there. All right, so then as I look at my chi right, my chi left, my chi right, chi squared right, is going to be 1 minus my confidence interval divided by 2. So that's going to be 1 minus, this is a 90%, excuse me, divided by 2. So this is going to be 0.05. All right, so now then when I try to find the left, okay, they have you using 1 plus your confidence interval divided by 2. It's going to be 1 plus 0.9 divided by 2. It's going to equal 0.95. Okay? Hold on just a second for me. Okay. And if you notice what I was telling you just a second ago, that we could also calculate this as 1 minus the 1 minus 0.9 divided by 2. Okay, if you calculate that, you also get 0.95. And if you think about the fact that this is also that my left chi is going to equal 1 minus my right chi. Okay. However, it helps to kind of have your brain think about that. Okay. All right. So I've got those two figures. I've got the idea that, there's my numbers there, and my right chi is going to be 0.05. My left is going to be 0.95, right? Okay, so I'm going to take and I'm going to use there's a table in the back of the book. Yay, we're loving those tables. Okay, so they've given you a picture of the table here. If you look at the table, you notice right up there that they have that alpha symbol that I was telling you. Okay, so as I look at this, I've got the 0.95 and the 0.05. I'm going to go down this table down to 19, which is my degree of freedom. Okay, so that's going to give me here 10.117 and 30.114. Okay, so my right is the 30.114, my left is the 10.117, and that tells me then that 90% of the area under the curve lies between these two right here, right? So 90% of this area under the curve is between, this is my confidence interval, that 90% is between 30 and 10, okay? So that's what I'm looking at there. Okay, we go from there. All right, we're going to go from there, and we're going to look at the confidence interval for our variance and our standard deviation. All right, and we're using our chi. This right here let us calculate the chi left and the chi right, okay? And we're going to be using that as part of calculating the confidence intervals for those standard deviations. All right, so let's look at this. We've got two formulas on page 346. You see the formula for the confidence interval for your variance and the formula for the confidence interval for your standard deviation. Remember the fact that variance, remember for the variance, we took the population mean, the squares of the population mean. So that's where, that variance was this. And then remember our standard deviation? We then took that and we took the square root of it. So remember when we added up all of those, the population, when we added the whole thing up, it came to 0, and therefore what we did with each mean was we squared each mean and added them up, and that's how we got the variance, was by squaring each of them, and then we took the variance and we took the square root of it, and that's how we got the standard deviation. Just remember that idea. Okay, so as we look now at the confidence interval for our variance, okay, we're going to have that the variance is going to be less than n minus 1 times the sample variance divided by my chi left, and it's going to be less than that, and then it's going to be greater than n minus 1 times that sample variance divided by my chi right. Okay? Now then, when we look then at the standard deviation, it's just going to be the square roots of these two things. So over here, I'm going to have the square root of that n minus 1 times s squared over my right chi. Okay, So it's good. My standard deviation is going to be greater than that, and then it's going to be less than the square root of n minus 1 s squared divided by my left chi. Good? Okay. Let's see, look at then real quick, down here at that blue box that's just going to go through for us how we're going to go about this. So we want to construct the confidence interval for the variance in the standard deviation. So we're going to start by verifying the fact that the population has a normal distribution. You're going to be told that as part of the problem. Okay, then we're going to identify the sample statistics. You're going to have n. You're going to have your degree of freedom, which is just, n minus 1, right? You need to have that. You're going to need to find your point estimate, and it's going to be the same formula that we've been using all along. You'll find your critical values for your chi left and right. You're going to use the sample table for that, like we did just a moment ago. Okay, remember we were up here, we had found right here that chi right number, we'd found that chi left number, and then we went to our table and we looked these up using our degrees of freedom. Okay, so you're going to do that, and then you just see down there where you're going to find your left and right endpoints to form the confidence level for the variance, and then you're going to find them for the standard deviation. Okay? All right, so let's run through an example real quick here. Examples are great, right? Okay, so I am running through with you example 2. All right, we randomly select and weigh 30 samples of an allergy medicine. The sample standard deviation, is going to be 1.2 milligrams. Okay. And, the sample standard deviation is going to be 1.2 milligrams, assuming the weights are normally distributed. Construct a 99% confidence interval. So we want a 99% confidence interval for the population variance and the standard deviation. Okay, so remember that our degree of freedom is going to equal 29 then, right? Okay, so we've got this right here. It says the areas to the right of chi R and chi L, the area to the right of chi R. So we need to find our chi squared right. All right, just like before, we're going to take 1 minus that confidence interval of 0.99. We're going to divide that by 2. Okay, so that's going to give us this 0.005 for right. Okay, and then remember then for chi left, for me, I'm just going to take 1 minus chi right. Okay, but the way that they're going to do it in the book is they do 1 plus that 0.99 divided by 2 is going to give them 0.995. Okay, for me, I would also have found this by just doing 1 minus 0.005 would have also given me that 0.995. So again, whichever way makes sense to you. Okay, so those are my numbers that I've got here. So I have this, and I have this. Okay, and over here is going to be my degree of freedom. Okay, so using that, go to the back of the book, and you're going to look these up in the table. When you go to the back of the book and you look this up in the table, you're going to find chi squared for the right is going to be 52.336. You're going to find chi squared for the left is going to be 13.121. Okay, and that table for that, why am I deciding that I will look this up for you? I can't remember. Oh, yeah, it's table number 6. That's going to be on A19. All right, so that's what the table that you're going to use for this right here. Okay, so using these critical values, and we've got that idea that our sample standard deviation is going to be 1.2. All right. we're going to go ahead and use the formulas that we had over there from page 346. We're going to use those formulas and we're going to plug these things in. Okay, so remember I had the n minus 1 times the s squared over my right chi. Okay, so 30 minus 1 is going to give me 29. That's my degree of freedom, times the 1.2 sample standard deviation square divided by my right chi, which is 52.336. That's going to give me about 80. Okay, and then let's look at the other one. I've got this 29 again, the 1.2 squared again, but then this is going to be divided by 13.121. Okay, so that's going to give me about 3.18. Okay, and this is going to be my confidence level for my confidence interval for my variance. Okay, so that variance is going to be between 8.8 and 3.18. Okay, so that's going to be my variance. So now let's look at the standard deviation, the confidence interval for the standard deviation. Okay, so I'm just taking, if you look, it's going to be the square root of that and the square root of this right here. Okay, so when I do that, when I take the square root of each of those, I'm going to get 0.89 and 1.78. Okay. Yep. All right. So with that, we're going to find that with 99% confidence, we can say that the population variance is between 0.8 and 3.18. And the population standard deviation is between 0.89 and 1.78 milligrams as we're looking at that allergy medication. Okay. All right. That is it for this one. Again, very similar to the other things that we've done, just needing another formula. I hope you guys have yourselves a great day.